Hey, hi, I'm going to show you guys how to make this definition in Grasshopper and export the curves for laser cutting. So just a quick overview, here's basically what we would end up with. For example, if I cut this out of wood or cardboard or acrylic, just a very simple screen. So this definition is pretty simple. It outputs the curves. Let me zoom out here. It outputs the curves over here, a surface, and a 3D extrusion. And really all we need to laser cut is this bottom one. The other pieces are for just visualizing what we would end up with. So I'm going to just walk through this from the beginning. So this definition starts with a basic grid, an 8x8 grid, and then I offset the curves just like we did in class, and they're offset by 1/8 of an inch, so 0.125 inches. And the purpose for that is, in this example, what I want to cut out is the little squares that make up the cells, and so they need to be offset to have thickness. So I'm going to hide this grid, and then those are my two curves, so an inside and outside curve. And then if I fill the two curves with a surface, I end up with something like this. So these are actually separate. I'm going to hide these. These are actually separate pieces. So there's 64 of them. And that's not going to really work for just generating the profile curves of everything. So you have to use a solid union connected to a surface, boundary surfaces component, to essentially create kind of a solid surface, an open B-rep. And then what you have to do is get the edges from the B-rep, and then join the curves, so then you can get this sort of result. So once I do that, I have my curves, and then I can visualize that as a surface. I can visualize it as just the curves, but transposed here to the right. And then I can also visualize it as my 3D extrusion. This logic right here is just to basically position these visuals here and also take care of the extrusion for the 3D piece right here, which right now is just a 1/4 inch thick. So with that, the next step would be to, once you have your curves in a place like this or close to this that you want to export, for instance, back here, if I wanted to export just the offset curves for further processing in Illustrator, I could just right-click on this and say Bake. Bake to my default layer, and then if I zoom out in Rhino and look at them, this is what I end up with. So this is pretty much what we ended up with in class. I baked out these curves and then did some offsets, or manipulated the data in Illustrator. But in this case, I'm just going to bake out what I produced right here and then position it in Illustrator for laser cutting. So I'd go to my end result here, the curve, bake it, and then it shows up here as my curves. So I'm going to go ahead and join just to make sure nothing is left unjoined. Actually, looks like everything is. So I'm going to group in right now, and then while that's selected, I'll say export selected, and I'll save out an Illustrator file. So it's going to save out the curves. It's going to replace the one I had. And this is important. You want to make sure your scale is set correctly. So you have, I'm working in inches, so I want to make sure that is equivalent to inches. My file is in inches in Rhino. So let's say export. Okay, and then I go over to Illustrator and we'll open it up. So this is my file. Open. And you might have to zoom out. Okay, so those are my curves. Bring them over here. So notice it's a bunch of paths. They're not grouped. So I'm going to just select Command G, group, and that looks pretty good. So depending on which laser you use, you want to make sure you set up your artwork to either be on an artboard that is contained to the artwork boundaries, or you want to set up an artboard that is the size of the machine bed, the cutting area. So in the case of an Epilogue Fusion, it has a bed size of 40 by 28 inches. So I'll say OK, and go back to here, and I will copy this over to here. And in the transform here, you can see, okay, it's 8.25 inches in both directions. So I want to make sure this is maybe positioned at 1/4 inch from the top left. So say I have a piece of material that I'll visualize here with just a rectangle. I have a piece of material that's 12 inches by 12 inches, something like that. This is just for seeing it. So say I make it just kind of have a stroke of orange color and put it up at 0, 0. So right there I can see, okay, the piece that I want to cut out, it's within the bounds of my material. So this could be cardboard, acrylic, wood, any kind of material that's safe to go into a laser. And so the next step would be to make sure with whatever system you're using that you have the machine settings associated with the geometry you're going to cut, or the curves you're going to cut. In this case, if I wanted to cut all this out, I'd probably assign it to a red color. I use red as the color for indicating cuts, and black, filled black areas for engraves. For example, an area like this would be considered an engrave. Like that. And the laser would basically go back and forth and cut away a little bit of material at a time. So next step would be save this, and there's two file formats that work best with laser cutting, Illustrator or an EPS file. Either one should work or be accepted by the IdeaForge. And any further configuration you need to make to your file, I'm sure you could get help with. But this is the most important part, just kind of getting your geometry from Rhino out and into a program that's much easier to sort of lay things out and color them and stuff. You can also handle the coloring of of geometry within Rhino by assigning geometry to a particular layer. So if I move this to a new layer and change the color to red, for example, it will actually show up as red in Rhino here. And then when you export it from Rhino, it will show up as red in Illustrator. So you can manage the color in here or in here. So I hope this video helped. I will upload these files to our class GitHub repo, and let me know if you have any questions on this process.